The abandoned ironworks nobody could explain. In the winter of 1891, workers in a remote European valley reported something that should not have been possible. An iron processing factory, isolated from coal routes, river turbines, and early electrical grids, continued operating for years without any visible fuel source. No smokestacks, no boilers, no furnaces burning day and night. Yet the machines moved. Presses stamped metal. Conveyors rolled endlessly. Night shifts worked under steady mechanical motion. First, locals assumed secret coal deliveries. Inspectors found none. Others suspected hidden steam lines. No pipes. No pressure tanks. What baffled everyone was not just that the factory worked, but that it worked silently. No roaring engines. No rhythmic pounding of pistons. Just a low, constant hum, almost like wind moving through iron ribs. The building itself was unusual. Thick stone walls reinforced with massive iron ribs arranged in precise geometric patterns. Copper bands ran through floors and walls, not wired like electricity, but embedded as if part of the structure itself. Workers joked that the building felt alive, vibrating faintly under their boots. When the factory finally shut down after its mysterious owner vanished, historians dismissed it as exaggeration. Records were sealed. Blueprints disappeared. The site was classified as economically insignificant. Yet one detail refused to vanish. When engineers dismantled one remaining machine decades later, they found no power input mechanism at all, only rotating assemblies, layered metals, and magnetized cores aligned with precise orientation to the Earth itself. Engineers who listened instead of forcing power. Unlike steam engineers of their era, the designers of this factory did not attempt to overpower nature. They observed it. Their notebooks, fragmented but authentic, show calculations based on direction, latitude, and diurnal variation. Instead of pressure and combustion, they measured subtle forces: drift, oscillation, and field density. They believed the planet itself was active, not inert. The machines inside the factory did not generate energy in the traditional sense. They redirected motion already present. Slight mechanical imbalances were amplified through rotational symmetry. Materials were chosen not for strength but for response, how they reacted when exposed to environmental forces. Iron cores were layered with copper spirals, not to conduct electricity as later understood, but to guide interaction between motion and field. Bearings were deliberately imperfect, creating microscopic delays that sustained rotation rather than halting it. The engineers believed friction was not the enemy, resistance was information. Every vibration told the machine how to adjust. What they built was not an engine. It was a listener. Why conventional science could not accept it? The problem was not that the factory violated physics. The problem was that it did not fit economic logic. The same moment these machines operated quietly, massive investments were being poured into coal infrastructure. Railways, mines, refineries. Entire empires were organizing around fuels that could be owned, taxed, transported, and controlled. A machine that required no fuel posed an impossible question. Who profits from something that cannot be sold repeatedly? Scientists sent to evaluate the factory struggled to categorize it. It did not burn fuel. It did not store energy. It did not produce power as textbooks defined it. Instead, it operated by remaining in continuous alignment with environmental forces. So the reports were reclassified. Not as fraud, not as error, but as irrelevant. University curricula slowly narrowed. Only energy that could be isolated, stored, and monetized remained valid. Anything ambient, anything continuous was labeled impractical. Within a generation, the intellectual tools required to even understand the factory were gone. Modern experiments that accidentally rediscovered the same principle more than a century later, something strange began happening again. Independent engineers experimenting with unconventional motor designs noticed unexplained efficiency spikes. Certain configurations refused to slow down. Others delivered mechanical output far exceeding expectations, not enough to break laws, but enough to raise uncomfortable questions. When analyzed closely, the similarities were impossible to ignore. Rotational symmetry mattered more than raw input geometry affected performance, as much as material orientation relative to Earth altered behavior. Intermittent resistance sustained motion instead of killing it. Most importantly, these systems behaved differently when isolated from environmental interaction. Shield them too well and they weakened. Expose them and they stabilized. Mainstream science dismissed these effects as measurement error. Funding evaporated. Journals declined publication. But the experiments continued quietly, shared in obscure forums and private workshops. What these modern builders stumbled upon was not free energy. It was energy participation. What this means for the future of civilization: if systems can be built that cooperate with natural forces instead of consuming finite resources, the consequences are enormous. Energy would no longer be extracted, IT would be accessed. Factories could operate without combustion. Remote regions could function independently. Energy would become decentralized by necessity, not ideology. And that is the real reason this knowledge vanished. Because control requires scarcity, and scarcity requires dependence. The old factory did not fail. IT was ignored into extinction. But the principles never disappeared. They waited. In forgotten notebooks. In unexplained efficiency anomalies. In machines that refuse to behave like textbooks predict. The question is no longer whether such technology is possible. The question is whether society is ready to allow it.